Thank you, Jason. Welcome everybody to today's session. My name is Saleem Bseeu. I'm program manager from Azure Network Security in Microsoft. And today we'll be speaking about the new SKU, which is now in public preview, and that's the Azure DDoS IP Protection. I'm going to be also speaking, of course, about our original SKU and go over demo and other details. So let's have a look at our today's agenda. We will cover the DDoS attack trends that were published from Microsoft, the Digital Defense Report for 2022, as well as some of the different attacks types that are used to take enterprise down. We will also look at Azure DDoS protection offerings and go over some of the key benefits in implementing the service. And at the end, I will also show you a demo of how to configure Azure DDoS IP protection and how to investigate DDoS mitigations during DDoS attacks. So let's start with the DDoS attack trends and types. So the first thing, let's zero in on the DDoS first. So DDoS stands for Distributed Denial of Service. And it's an attack where bad actors send large floods of illegitimate traffic to an application or network, primarily using some sort of a botnet to accomplish the disruption. So botnets are primarily made of compromised IoT devices, personal workstations, and servers that have some sort of malicious software installed, where a bot master or a bot herder can control remotely from anywhere. And usually the goal is to take down the service by exhausting the application's resources or even the resources of middle box, like a firewall or some servers that you have in between. So this can result like in a poor website or application performance, or it can take down your service altogether. This style of attack is one of the biggest security concerns of today, as it can be costly to your business, and it can also be incredibly cheap and easy for bad actors to initiate these attacks. So why should you care? Well, any public IP is vulnerable to a DDoS attack. Any public IP that you have out there, and for example, if you have a Azure public IP, then it's vulnerable to this attack. And it is one of the top causes for servers' ability to go down for large enterprises. Again, a DDoS attack, if not mitigated, can be costly to your organization because of a loss of customer interaction with your backend or dynamic resource scaling to handle the volume of a new traffic coming in. So DDoS attacks are rampant. Over the past year, attacks experienced around the world have been unprecedented in volume, capacity, and frequency. Microsoft Digital Crime Unit, DCU, identified the cybercrime as a service, merchant offering distributed denial of service on a subscription level. And this model outsources the creation and also maintenance of the botnet necessary to carry out the attacks on the SaaS merchant. Each DDoS subscription customer receives an encrypted service to enhance operational security in 1 year of 24/7 support. The DDoS subscription service offers different architectures and attack methods, so the purchaser can simply just select like a resource to attack, and the seller provides access to a array of compromised devices that they have and that they can use to initiate the attack from. And the cost for DDoS subscription is around just $500 US. We are also seeing the rise of citizen hackers. So social media platforms enable the rapid organization and mobilization of thousands of would-be citizen hackers who were provided directions for conducting easily executable attacks such as DDoS attacks. So most attacks observed over the past year were shortly lived. Approximately 28% of the attacks lasted less than 10 minutes, 26% lasted 10 to 30 minutes, and 14% lasted 31 to 60 minutes. 32% of these attacks were more than an hour in duration. So as you can see, like usually DDoS attacks are very short in the duration of time, but even in 10 minutes, it can still bring down your service. The the gaming industry continues to be the top target right now for DDoS attacks, mostly from mutations of Mirai botnet and low-volume UDP protocol attacks. Since UDP is commonly used in gaming and streaming applications, the majority of attack vectors were UDP float attacks, while some small portion of them were UDP reflection and amplification attacks. In the past year, the attack vectors commonly employed were user data protocol UDP reflection on port 80, using protocols such as simple service discovery protocol, DNS, and also NTP, which is the network time protocol, compromising one single peak. The DDoS of all the DDoS attacks that were detected over the past year, 54% were conducted against targets in the United States, a trend that might be explained by the fact that most of the Azure and Microsoft customers are in the United States. But we've also seen a sharp uptick in the attacks against India, from just 2% of all attacks in the second half of 2021 to 23% in the first half of 2022. East Asia, Hong Kong in particular, remains a popular target at 8%. And for Europe, we've seen like some concentrations against Amsterdam, Vienna, Paris, and Frankfurt regions. We attribute the high volume of the attacks in Asia to the region's huge gaming footprint, especially in China, Japan, South Korea, and India. And this footprint will continue to expand and increase with the smartphone penetration, penetrating the popularity of mobile gaming nowadays, suggesting that this geographic region will be targeted, and the DDoS attacks will continue to rise. So let's review some type of the attacks for DDoS. We will start off with the volumetric attack. So these type of attacks, volumetric attacks, use a massive amount of traffic, which saturates the bandwidth of the target and the victim system. Volumetric attacks are easy to generate, either using DDoS for hire services or with attacker employing simple amplification techniques. It generates such a high quantity of traffic that it completely blocks access to the system, like website or a service, or sometimes also momentarily like makes it a bit slow, or users will notice that the applications don't work correctly because of the saturation in the traffic and the bandwidth that's going to your to the workload. And these attacks are measured in bits or packets per second. And some examples of these attacks are ICMP flood, IPsec flood, and UDP flood. The next type of DDoS attacks are protocol attacks. So protocol attacks are also known as state exhaustion attacks. And these type of attacks causes service disruption by consuming all of the available capacity of the web application servers or the capacity of the intermediate resources. And intermediate resources can be something like firewalls, load balancers, anything that you have in between your workloads and the attacker or the user. And it abuses the flows on the network layer for protocol attacks. So it abuses protocols like IP, ICMP, and IPsec, and the flows on transport layer, exploiting flows in the TCP UDP protocols. So the most common example is a TCP sync flood attack, and this attack exploits the TCP handshake by sending the target a large number of TCP sync packets, or the initial connection request, with spoofed source IP addresses. So then when the victim machine responds to each of these connection requests and keeps waiting for the responses to finalize the handshake, which is in this case will never happen, all of these requests will stay in the open state waiting in the virtual machine itself, waiting for a response. And because they increase over time and over how many different source IPs are coming these requests from, it causes the system to exhaust all the resources that you have in your machine, and also becomes unresponsive or very slow to respond. The third type of DDoS attacks are the resource attacks. So the resource attacks or application layer attacks are layer 7 attacks that target the backend server. These attacks, or the goal of these attacks, is to exhaust the resources of the target application and to abuse the flows and vulnerabilities on the application itself. And for example, targeting web pages and web servers with HTTP request, a single HTTP request is simple to execute on the client side, and it demands a lot of computation from the target server to respond, right? Because the target server will load many files and also run some database queries or other workloads. And this type of attack is a challenge. It's very challenging to identify and to defend against, unlike the first two types of attacks, because because the traffic usually seems legitimate, even though it's not. It doesn't have to be very huge in like TCP number of packets, and it can be, and for sure it can be also malicious. So the DDoS by itself does not protect against layer 7 protocol attacks. And in this case, for Azure, it's better to use the web application firewall, such as the Azure Application Gateway WAF or the Azure Front Door WAF with the Azure DDoS protection to protect against layer 7 attacks. So let's go over the Azure DDoS protection service we have in Microsoft. For this call, we'll mostly speak about the new SKU, which is in public preview. However, I will go also a bit about the original SKU, or the one that we currently have, which is Azure Azure DDoS Network Protection. And the Azure DDoS Network Protection is a cloud scale DDoS protection for virtual networks in Azure. And basically what this means is that when the Azure DDoS Network Protection works with plans, where you can enable it or create a plan, and then you can protect all of your VNets under this specific plan. And with this plan, the pricing, or the public IPs you will pay for the first 100, and then anything over will pay $30 extra. And I will in a bit show you what's the biggest difference between this plan and the new SKU. But before going there, the Azure DDoS Network Protection has Azure Global Network capacity, adaptive tuning, attack analytics and metrics, integrations with Microsoft Defender for Cloud and Sentinel, DDoS rapid response, and SLA guarantee and cost protection. And I'll go into more details in the upcoming slides. Now, the new SKU, which is now in public preview, is the Azure DDoS IP Protection. So this new SKU gives you the ability to protect just one public IP, or less than 100 public IPs if you want. So this is really good for customers. Let's say if you have like 3 to 10 public IPs and you want just to protect these public IPs, you don't have like 30 or 60 public IPs you want to protect with a plan. So you can use this new SKU. So it's cost effective, and also you'll get the enterprise grade DDoS protection with this SKU. You have the flexibility to enable it on any specific public IP you have. It doesn't matter if they're in the same VNet. It's very easy to configure and monitor, which I will show you in the demo. And of course, there's also the integration with Microsoft Defender for Cloud and Sentinel. So the SKU comparison between the network protection and IP protection. As you can see, most of the features are the same. The difference here is that network protection also has DDoS rapid response support, cost protection, and WAF discount. While you can see that the IP protection still has all of the other features. So some of the features we have on the DDoS protection. So DDoS protection, or Microsoft DDoS protection, is a worldwide scale, where we have 62 regions, 60 terabit per second mitigation capacity, 1900 attack mitigations daily. So that's the number of DDoS attacks that are mitigated daily, around this number, and also inbound and outbound DDoS mitigations. The Azure DDoS Protection has a feature which is called adaptive tuning. And what this basically means is that you don't really need to do any extra configuration other than adding the public IP under DDoS protection, either the network protection or IP protection. And the adaptive tuning, how it works, it will have a threshold or three policies or three thresholds for each public IP that you're protecting. It will have a threshold for TCP traffic, TCP sync, and also UDP traffic. The public IP is monitored all the time, and we are using machine learning algorithms to adapt that threshold and also setting the mitigation. Now, when you enable the public IP, the DDoS on the public IP, you should know that you will have three thresholds. So you don't have to worry about like different types of traffic, if it's UDP or TCP. And also the adaptive tuning, it uses it is adapting based on the traffic that is going through the public IP, and also it looks at the scaling that is happening on the service where it's attached, the public IP, and will set the threshold accordingly to that scaling that is happening. Now, this adaptive tuning, as I said, there's no extra configuration. It's just enabling the DDoS protection public IP, and it's already running. And I will show you later how to find the threshold for each public IP and also look at the mitigations. So of course, with the DDoS protection, you also have attack analytics and metrics. So you can use the telemetry with the Azure Monitor. You can see real-time network attacks, mitigation flow logs, and also snapshots for mitigation reports every 5 minutes, and also post-mitigation summary. And you can send the logs to different places like Microsoft Sentinel, Splunk, and Azure Storage. We have also a workbook which gives you a report on the DDoS mitigations and attacks, and I will show you in the demo how it looks like and where also you can download it from. There's also the integration with Microsoft Defender for Cloud, so you get recommendations for unprotected public IPs. You have also alerts in the same dashboard, and also some regulatory compliance recommendations based on the standards. So let's have a look at the pricing. The first one, which is now already available, the network protection, is a fixed cost. It's $3,000 for the entire tenant. So any subscription or VNet you have under this, you can protect under this tenant, and that's for 100 public IPs. For each public IP extra, there is a $30 per month extra charge. So with what this pricing includes for the plan, a network plan, is that you will have the cost protection against scaling out if there's a mitigation, if there's an attack, and some of your services that are protected by DDoS scales out, then you get the cost protection for that, and also you get the access to the rapid response team, which is the team that supports you for the DDoS cases. And normally it's around $75,000 for a year for this service. Now with this plan, if you are protecting a specific VNet, and in that VNet you have a WAF configured on application gateway, then the WAF is discounted 100%. So you're not paying for the WAF in that VNet, and the scaling out, of course, as I've mentioned, of VMs, AKS, or load balancers. Now let's have a look at the cost for the IP protection. So this is the new SKU, which is in public preview. So just a reminder, currently, since it's in preview, public preview, there is no cost, and it will the cost will start from 1st of February when it goes GA, and it should be around $200 per month for each public IP you're protecting with the IP protection. So let's jump over to demo, and I will show you how to configure the DDoS PRIP, and also show you how to investigate DDoS attacks and looking at the workbook and the logs. Now, as you can see here, I have my public IP. So this is the public IP that I'm going to be enabling the DDoS protection on. And from the overview, if we go down here to the right, you can see protect IP address. Now, if you want to use Portal, Azure Portal to enable the pure IP protection, then you have to go and log in using the preview Azure Portal, as you can see here. Since it's public preview, then you need to use the preview, and then you will see this option here on the right down corner. So if I click on protect here, it will give me 3 options here. As you can see, right now it's showing me protected, since I have selected the second option, which is the IP protection. And after you select this option and save it, that's all you need to do from configuration-wise to enable the DDoS protection and against DDoS attacks. So the other 2 options we have here, the first one is the network protection, and this is the Azure DDoS network protection, or before we called it standard. If I select this one, and it will inherit the DDoS protection from the virtual network, where we have this public IP attached to the service, right? So if you are using the network protection, and you're protecting this VNet where this public IP is, then you should enable the network where it will use that plan. If you want to use DDoS IP protection specifically for this public IP, then enable the second option, which is IP. And now, as you notice, we have also disabled. So specifically what does disable do? It gives you the ability to exclude public IPs from the network DDoS protection. So if you're using the network DDoS protection, and let's say for example, if you have like 50 public IPs and you want to, in the same VNet, and you want to protect like only half of them, right? So if you have 50 and you want to protect 25, then what you can do, you can go to this to the public IPs you don't want to protect with the plan, and you choose disable, and it will here warn you that this is disabled and you will not receive any protection, even if configured at the virtual network. So for our case, and for this demo, I will select the IP protection, and I will click save here. So the IP protection is already it's already in this specific configuration, so I don't need to do it. Let me just cancel here. Now I've enabled the IP protection for this public IP 2 days ago, and or a few days ago, and I have also simulated a few DDoS attacks on this public IP, and now I will show you how we can find these mitigations or DDoS attacks, and how we can investigate it. The first place we will go to is the metrics, right? So we go to metrics, and we want to find out what's the threshold we have for this public IP. So if I go down here, we have the option here, the metric inbound sync packets to trigger DDoS mitigation. And this is the option, this is the metric where it shows you the threshold for the sync packets for this public IP. And you can see the threshold is 20,000 packets per second, and it didn't really change, it at the same level. Now, as I told you earlier, we have 3 thresholds. So the first one is sync. If I want to have a look at the TCP at the UDP, for example. So this is the inbound UDP packets to trigger the DDoS mitigation. I click on it, and I can see it's at 40,000 per second. And then we have also the TCP sync. Now, since, as I told you, we did the simulation attacks, and I want to see, hey, like, where was I under an attack or not? What I will do, I will go to the bottom here, and we have one metric called under DDoS attack or not. So let's select that one. And as you can see here, we have a DDoS attack, but right now it's looking at the last 24 hours. So let's look at the last 2 days, and it shows us this data. So as you can see, it shows me here 0. 0 means that we are not under DDoS attack. And you can see November 3rd, November 4th, like at half the day, there was nothing. And then we have here 2 spikes. And you can see each one of them shows the DDoS under attack with 1, which means that the mitigation started and the DDoS protection thinks that we are under an attack. Now, when the DDoS mitigation starts, it doesn't really mean that it will start, of course, dropping all the traffic. It just means that the traffic that's going to that public IP is being routed to a mitigation pipeline, and if there's any legitimate traffic, it will be dropped. So we can see here that at November 14th, 4:07 p.m., there was a DDoS attack, then another one at this time. So let's have a look at the amount of traffic that was going through this public IP and see if it also matches with when the DDoS mitigation started. So I'm gonna add another metric. Actually, let me add another chart here. And for this one, let's look at the TCP package sync count. So sync count, it will show us the average. And what you'll notice here is that there's these 2 spikes here, and it correlates exactly with when the DDoS mitigation started. And you can see there's here 16 million packet sum of 16 million packet, and then here another attack for 4 million packets. And you can see that that's when the DDoS mitigation is running. So with these metrics, you can see, of course, like when there's a DDoS attack, and it's always recommended to set an alert, of course. So as you can see here, if you click on new alert rule, it will go to the create an alert rule, and here you can have some specific condition, which is like if it's 1, then send an email or SMS or your choice of action that you want to see. So let's go back to the metrics. I've showed you now that we know now that there was DDoS attacks, we saw the spike, but now we need to see, or we need more details, right? So we want to see like where the attack was coming from and what exactly happened. So first thing, I will go to diagnostic settings, and this needs to be configured before, of course, DDoS attack. So in the diagnostic settings, we have one diagnostic settings here, which I've configured before, and I have enabled these 3 categories. And my recommendation is if you're using DDoS protection, then you should enable all of these categories. I mean, for all the public IPs you have, so you have all the reports and the mitigation flows. So we have the DDoS protection notifications, the flow logs, and also the reports, which are enabled. And I'm sending them to my workspace, which is called Cybersecurity SOC. And later I will show you in a bit how we can look at the logs. Now, this setting should be, as I said, like on most of your public IPs. And if you have like many public IPs, and it could be a lot of work, like to go to each public IP and just enable this. What you can do is you can use an Azure policy, and I will show you right now. So I'm going to go to my other tab where I have the policy, Azure policy opened, and under definitions, I search for DDoS here. as you can see here. So it will show me these definitions. Now, if I look at the second one, public IP addresses should have resource logs enabled for the Azure DDoS standard protection. And now what you can do, you can use this definition to configure a policy which makes sure that all the public IPs you have in some specific, let's say, subscription have always the logging enabled for DDoS. And what else you can do here is you can have specific or all VNets in a subscription also added to your Azure DDoS protection. So you don't have to do it manually. When you add a new VNet, it's automatically protected and added to the Azure DDoS plan. And of course, we have also another definition where you can also control this using the tag on the VNet itself. And you can find this in our Azure Network Security GitHub repository. So after looking at this, let's go back to our public IP diagnostic settings. So as I've said earlier, we are sending these logs to the cybersecurity SOC. So let's go to that work analytics workspace. So I'm going to go to log analytics workspaces here. And we have the cybersecurity SOC. I'm going to go under the logs here. And over here, the Azure DDoS protection uses Azure Diagnostics tables to store the logs. So I'm going to paste here one of the categories that we want, which in this case is the mitigation reports. So it's a basic query. It just looks for this category for the DDoS logs. So I'm going to add the time range to 48 hours, and I'm going to run this query. Let's go and add this a bit more for 3 days. Let's have a look, mitigation reports. And it's not showing anything. So let's try with the notifications here. Azure DDoS notifications. And these DDoS mitigation reports, I'll also show you later how we are using them in our workbook. So once I search for DDoS protection notifications, right, I see we have a few logs here, and let me actually go to 48 hours. Okay, now if I open this one, the first one, we can see that this one shows that the mitigation stopped, but let's go first to another one where we want to see where it started. And here we have it. So this log, which is from the category DDoS protection notifications, it sends you a log. It sends you a log when the mitigation starts, right? So it tells you for this public IP, the mitigation started, and here in the message, it tells you the mitigation starts for this public IP because the inbound traffic exceeds infrastructure default threshold. And using this information, that the mitigation started and there is a DDoS attack. And of course, you can also create an alert for this specific log. So if you receive it, you receive an alert on your email or SMS. And the second DDoS protection notification you should get is when the mitigation stopped. So this one shows you that for this specific public IP, the inbound traffic is below threshold and the mitigation stopped. Now, as you can see, this information it just tells you when a DDoS mitigation starts and also when it ends. But if we want more information or if we want to go really deep, then we can use the DDoS mitigation flow logs. So unlike the notifications, the flow logs, once the mitigation starts, it will log all the packets that are going to that public IP. And it will show us all the traffic that is going, both legitimate and illegitimate. And it will show us or tell us if that packet was dropped or if it was passed through and it was seen as a legitimate traffic. And as you can see, we have here more than 30,000 logs, and that's because we have a lot of traffic going on that when there was an attack. And let me open one of these, and I think most of these will be legitimate traffic because we didn't have that much traffic going through that public IP, so most probably it's going to be the attacker. So let's open this one. If I go down here, we can see the category, DDoS mitigation flow logs. It's going to this resource group. Then we go down here and we see that the message for this log is protocol violation invalid TCP sync, which means that the mitigation pipeline has seen this packet as a legitimate and part of the DDoS attack. And the reason is because of a protocol violation, because of the invalid TCP sync. And we can see here also the source public IP. So we can see exactly from where the attack was coming from and the specific packet. And we can see also specifically like from which source port it was using. Also the destination, of course, which is our public IP, and the destination port, which is the HTTPS 443. So with all of this knowledge, it's sometimes it's a bit hard. Like if you're managing a few public IPs, it's quite difficult to really have a overview of what's happening, and it's a bit difficult to go one IP by time, right? So we have a workbook which you can use, you can install, and I will show you now. I have it open in this last tab here. Let me zoom out. So we have here we have the Azure DDoS Protection workbook, and you can use this workbook if you're sending your traffic to the work analytics place. So this workbook, as I've seen here, I've chosen this specific workspace. My time range is the last 90 days. And for the public IPs, I've chosen all of them, right? So all logs for the public IPs that are sent to this workspace, I will see them here. And you can see here, I can also choose specifically which public IP I want to see. But let's leave it like this. Now, under here, you will see we have the traffic overview. And this basically tells you the traffic overview for the logs when the mitigation was running, right? So when there was the public IP was under DDoS attack. And we can see here it shows you the total number of packets, which is 28 million. How many packets were dropped? You can see it's very close because we were mostly using this public IP to simulate DDoS attacks. Total TCP packets, how many were dropped, UDP dropped, and also other packets. Here on the left side, what we have, we can see all the DDoS attacks and the mitigations. So we can see, if I want, I can select this specific entry and it will only show me data for this specific one. Let's unclick it. And on the right side here, you can see the specific resource where you had the attack. And in this case, it's the application gateway that we have. If I go down here, we have the percentage. So it shows you, for example, the protocol, like 92% is TCP, 7% is other protocols, the continent of origin, the countries of origin, and in this case, 87% of all the packets that we have, or the attackers, came from USA, and the rest from United Kingdom. And we can see also the specific AS numbers, where it was coming from, and the drop reasons. So the drop reasons shows you what was the drop reason for the packets that were seen as illegitimate. And you can see here, it's a 51% is protocol violation, 33% also protocol violation with, let me see, there was, I think for a specific protocol, and then we have other packet flood. Now, if I go down here, you have the same number. And as you can see here, this is for the invalid TCP, and this is for the invalid TCP sync packets. If I scroll down here, this is the same logs that we saw earlier, which are the raw DDoS mitigation logs and also flow logs. Now, if I go to the second tab, which is DDoS metrics, here I scroll a bit down and I have also some interesting information. Here I can see, all the public IP address packet count or average packet count. And you can see here all the public IPs that you have, and you can see maybe sometimes, for example, like this entry here, you see there's a spike of traffic or anything. And also you can see, for example, here the thresholds, the one that I showed you earlier, but this one gives you a more aggregated view, and it shows you all the public IPs, that the ones that I've selected. You've seen like most of them don't have the information here because they're not really attached under the to the DDoS protection. However, 3 of them here shows you these thresholds that we have. And if I go down here, we can also see under DDoS attack or not. So here it shows you all the public IPs, the 16 public IPs that I've selected, and also if they were under a DDoS attack or not. So you have a very easy view for all your public IPs. So the last thing I want to show you, and that's the DDoS investigation tab. Under DDoS investigation tab, you have some information like allow traffic during mitigation. So this is the port number for the traffic that was allowed. And here you can see the port for the traffic that was dropped, right? So 88,000 were TCP 80, and you can see other protocols here. If I go a bit down here, we have the top attacking IPs. So if you want to know where most of the attacking IPs came from, or the bandwidth came from, you can see it here. So it gives you here some view over, like, for example, you can see that this public IP generated like 2,400 packets, and the same also, like we have here other public IPs. So you can also be knowledgeable about like where the top attackers are coming from and which public IPs. And under here we have also some DDoS mitigation activity. So you can see like when DDoS mitigation started or stopped, and also some like all attacked IP addresses in the logs, right? So this one, this workbook gives you really good view if you have like more than one public IP, and it shows you, all this information aggregated. And with this, I will be ending the presentation for now. I've showed you the recent DDoS attacks and different types of attacks. I've also shown you the new SKU, which is Azure DDoS IP Protection SKU, the features that were on it, and also the pricing, and also a quick demo on how to configure it, and also how to investigate DDoS mitigations and also attacks. I will then now open the floor to any questions that you may have. Please feel free to ask them in the chat, please.
Sure. Thank you, Saleem. The team's been great with answering all the questions, but we do have a few that might be worth reiterating. The first one is, will data captured by users in the metrics be used to refine the automatic tuning threshold in Azure dynamically, or will Azure update?
The traffic that is coming in, like from the mitigation stacks, are not taking into the account. It's mostly based on 2 factors, and that's the scaling that's happening behind the servers where the public IP is attached, and also on the type of traffic that is going through. So that's what it will use for the adaptive tuning.
Great, thank you. The next question is, how does the network IP disabled settings influence on the DDoS protection basic SKU?
So the DDoS basic protection SKU is there. It's always there, right? So for all these services that you use in Azure, there's always DDoS protection, of course. For example, if you're using some public service in Azure, then there's always a basic protection. Now that basic protection we've renamed to DDoS infrastructure protection, and that's because this protection is there to protect Azure infrastructure, right? So basically, yeah, there is always a basic or infrastructure DDoS protection, but it's there to protect the Azure infrastructure, and it's not let's say customized for the customer workloads, right? So attack like I've shown you could be seen as an attack for a customer or customer's workloads, But for Azure or Azure infrastructure, it's seen as a normal traffic and it won't mitigate it.
Great, thanks. The next one we have is, does Microsoft notify us during a DDoS attack? I know we would need to configure alerts as well through Azure Monitor.
So if you're using the Azure DDoS protection, right? Like doesn't matter if it's the network or IP protection. It's if you want to be notified, then as I've shown you, like the best way is to use the alert. And for example, like you can use the notification flow that you get, like saying, hey, mitigation started, and you can configure alert based on that log, and you will be knowledgeable about like when DDoS mitigation starts, and you can also follow it in real time. So that's usually the recommendation, and the best way to be aware of when there is a DDoS attack happening.
Great. And the last question is there a way to simulate safely a DDoS attack that can be used for customer demos?
Yes, absolutely. So we have two providers who we are partnered with. So the first one is Breaking Point. Breaking Point is a self-service simulation, kind of attacking platform where we have partnered with them, and you can use them to simulate a DDoS attack against your public IPs. Of course, you need to authorize the connection and everything, and then you can start the attack and see, use the DDoS protection, see how it works, how mitigation works, and all of this. And then you have the second option of using the red button, and they are the second provider that we have for DDoS simulation attacks, where they will initiate and they will do the DDoS testing themselves, and they will give you a report showing, like, for example, telling you, hey, like, you are protected against this type of DDoS attack and this type, but for example, like, layer 7 or something else, we know it passed through, so you need to configure something, to protect against these type of attacks. So yeah, the short answer is yes, we have two providers, and I think probably one of my colleagues have already provided also a link where you can find them and use the simulation attack platform that they provide.
Fantastic. I think that's all the questions we've got. So I'd like to thank you, Saleem and David, for being our guests today and for an excellent presentation. And thank you to the rest of the team who helped answer questions. At the same time, I would like to remind the listeners that the best way to ensure you don't miss any future webinars or major announcements is to visit our landing page at aka.ms/securitycommunity. And while there, you'll find easy ways to navigate and find the resources and learning content relevant to our security products and their communities. A good start would be browsing our bite-sized product videos, ninja trainings, recordings of past webinars, GitHub communities, and more. We'd love to hear your feedback on how we can improve these webinars. Please take a minute submitting your webinar feedback at aka.ms/Azure NetSec feedback. Thank you, and see you next time. Goodbye.